Hi, can I hear? Okay, yeah, I think we can start. So, hi everyone, thanks for inviting me. Yeah, my name is Weihan. Currently, I work as a software engineer at the Monetary Authority of Singapore. It's good to see everyone here, both on site and online. So today we are talking about AI. So I thought that it's apt for me to start with this image. It's actually from Avengers Endgames. So it shows the moment. Okay. So it shows when the moment when time travel was discovered by Tony Stark asking his AI assistant to conjure up an image of a Mobius strip. So I don't know how it works, but somehow time travel was discovered. But the AI that we have today is not as amazing as discovering time travel, but it can still allow us to build some useful things and hopefully interesting things. Yeah. Um, yeah. So these are the contents that I'll be covering today. So mainly a basic introduction to AI and Gen AI. It's more recent developments and some of the tools that you can use to get started. I'll also intersperse it with some demos and projects that I did in the past to show just some examples of the kind of things that you can build. And after the sharing, we can have Q&A and we can go through, some of the things that you guys can build, how you can apply AI for this hackathon. So just a little bit about me. I started as an architecture student, like I think most of you. And after architecture school, I worked for about 2 years as urban planner. And during my work, I was doing some self-learning on data analytics and AI, and also doing some self-explorations. So it was at this time that I also found out that about this program called the AI Apprenticeship Program by AI Singapore. Which is a full-time program, and they have some AI tutorials lessons, and they also hook you up with an external organization where you can partner up to build real-life AI projects. So the thing that I did was sort of like a loan credit rating AI. It's an end-to-end sort of like pipeline to allow loan officers to decide when to issue loans. Yeah. So that was in end of 2012. So now about 1.5 years later, I'm working as a software engineer with the MAS, Monetary Authority of Singapore. Yeah. Yeah, by the way, these are all generated with the image that you see, all generated with ChatGPT. So actually the first prompt was just like a typical architecture student. I didn't even prompt it with any other thing, and somehow the AI, generated this image. So I thought that it's quite funny. Even the AI knows the experience, of going through Archi school. Yeah. So my journey started with generative AI. I guess everyone is familiar. So I remember it was all the rage back then when I was in school. That was in the middle of 2010s, 2016. So you tweak a few parameters, and then it comes up with a whole new design. Yeah, so these are just some of the projects that I did while I was still in school. Generating different iterations of buildings, different iterations of urban morphology, by tweaking some parameters, and also some simulation and optimization. Yeah. But the reason that I'm bringing up this is to illustrate a difference. Generative design in the way that we are familiar with, it's a rule-based system, it's a deterministic system. You input certain parameters, constraints, objectives, and it generates some iterations of the design. But my experience was that it can be difficult to craft each and every rule because typically you maybe use Grasshopper or maybe use some scripts and you have to code up each and every rule. But for things like designing an entire building or designing an urban structure, it's difficult to encode all the wisdoms and the intelligence that we have into this system. So this brings us to sort of like a different paradigm. So we'll start with a very brief introduction of conceptual understanding rather of AI. Yeah. So AI is a rather general term, and more often those in the field often refer to machine learning. So this is essentially different techniques that we use to teach machines, to train machines to learn with past data. So with the traditional paradigm that we see in generative design, we essentially we start with handcrafted rules, and we put them through the computer, and it generates some design iterations. But with AI or generative AI, we start with a vast amount of past data. So, for example, this can be images of all the buildings in the past, and also the accompanying captions. We put it all through the computer, and the computer, through thousands of iterations, it learns the patterns and the rules using the data that we have. And using these rules, and it then generates further designs. So it essentially frees us from having to meticulously code up or handcraft all the rules that we have.
Yeah, we're sharing in the system. Just need to make sure that it's recorded.
So this is just an illustration of the whole process. So we start with a vast amount of data, for example, images, and we put them through the AI model. Then we ask the AI model to give us predictions, and depending on whether the prediction is correct or wrong, we then the model is able to tweak the parameters, or rather the weights in the model, and through thousands and even more of iterations, it then sort of learns. And once we determine that the performance of the model is good enough, we then use this set of weights to generate further predictions or further images in this case. So this process is called inference. So since the end of 2012, with ChatGPT, the field has really developed quite rapidly. So every day, someone comes up with a new, better model, a new technique. So here, I'll just highlight some of the more, those that kind of make a difference, that kind of state, and kind of enable some new ways that we can build things. So we'll start with text. So as you may know, ChatGPT is powered by large language models, or LLMs. So it's essentially what it's essentially doing is just or rather the next token, like part of a word, a subword. So that's essentially what it's doing. But in order to do this really well, to really get the correct word, or the word that we want, it essentially have to learn some structure or some logic about our world through the text, through the vast text input that we use to train it. So by simply doing this really well, it essentially exhibits some emergent properties. It sort of like begin to get some understanding of the world, which enables us to do some interesting things. So what are the current limitations? So it still makes mistakes. For example, on the ChatGPT interface, it still says that it can make mistakes and not to trust the results fully. Because it's like a probabilistic model, so it can be difficult to get exactly what you want, the exact kind of output that you want. For a lot of models, there are still a limited number of input words and also output words. So the word limit, especially for text models. And also for there's an issue of knowledge cutoff, which is use the data to train the model, and there's a cutoff date for the data that we use to train. So past that certain date, we are not able to, the model is not able to learn from those latest knowledge, for example. Yeah. So some of the advancements that I'll go through later sort of like address some of these limitations. So this is ChatGPT. I think the most common way of using ChatGPT is, simply just describe a problem and asking it to generate a response. So this works in quite a lot of situations, but maybe for more complex tasks and even for maybe not so complex tasks like the one you see here, it isn't able to generate answers that is even correct. So because it's simply just doing next word prediction, so it's not actually doing the comparison or calculation. So for some of these tasks, it's not able to do well. So one way to address this is through prompting techniques. So there are a lot of research on prompting techniques. So this one is, for example, called the chain of thought. So essentially, we are asking the model to form a chain of reasoning before giving the final answer. And the way we do this is by, for example, providing some examples like a step-by-step breakdown of a problem and just different steps on how to solve the problem. And then the model is able to sort of like use this in the context, and when it's generating a new response, it is then able to answer in a similar way. So it will also try to break down the problem step by step, and then generating the final answer respectively after that. Yeah. So that's one way, or simply you can just code right in the context that please break down and then answer in a step-by-step manner. So if you do this, the model sort of also learns to break down a problem, but the result may not be as good as if you provide one or multiple examples. Yeah. So these are some of the other prompting techniques that people have experimented with and found useful. For example, no need to be polite, like asking the model please or things like that. Also, for example, include an intended audience. So you may say that please perform this task for a certain audience. So so in this way, the model is able to tailor the response based on your intended audience. And there are many more, but there's some funny ones also. Like you can ask the model to provide a tip. You can just say in your Eon context, I'll tip you a certain amount of dollars if you do this well. And apparently the model, is able to generate a better answer or more detailed answer if you do this. Yeah. So you can take a look at this source. And another limitation that we talked about earlier is the limited input word length and also the knowledge cutoff. So a way to address this is called this technique called the retrieval augmented generation, or RAG. So given a query, we then have a process to obtain the most updated context or some new context from a database. In this case, a vector database. So what it's essentially doing is just comparing your query with a set of contexts, and then retrieve those contexts that is most relevant to your query. And after we have retrieved for example, top n queries, top n contexts, then we'll append the context plus the query into the input to the model, and then the model is able to make use of these extra context in its answer to give you some more updated response. So this is called RAG. Yeah, so I'll show a demo here. So this is a project that I did last year. Okay, yeah. So this is sort of like a regulation, ARCHI or urban design regulation assistant. So okay, Yeah, so basically you input some query about some regulation, for example, fire safety or things like that. Then it's able to generate a response based on a set of context that we have that I have previously placed inside a vector database. So I think now you can do this with ChatGPT already lah. So they allow you to upload some PDF lah. I think last year this function was not there. So yeah, I did this when I was trying to find a job last year. Yeah. Okay. So for example, you can ask it about because one of the input document is the fire safety code lah. So for example, you can ask what are the regulations regarding maybe external walls for fire safety, for example. So on the back end, it's just doing the search lah to retrieve the top context, and then giving all the context to a LM to generate a response lah. So here I've included the links to the sources lah. Yeah, I think it's taking a while to load the PDF lah, but basically it takes you to the exact pages lah from where the sources are obtained. Yeah. Okay. I think that's all right. We'll go back to the slides. This is a rather big document. Yeah, so for example, it takes you to where the information was from. Okay. So actually currently with some prompt engineering techniques or with techniques like RAG, we can actually like solve quite a lot of problems like that we may want our LLM to solve. So you may hear people talking about training or fine-tuning models. Actually, with a large enough model, for example, with GPTs or some of the open source models, we can the model already sort of learns quite a lot about our world, some logics and things like that. So we can actually with the correct prompting techniques or with some of the techniques lah, you can actually do quite a lot. So for a lot of problems, actually, there may not be a need to fine-tune models. Yeah, I don't think anyone is talking about training their own LLMs because it really takes a lot of resources lah to train, and also a lot of expertise lah. So yeah, so actually the first three like prompting techniques are RAG. With those you can actually address a lot of problems already. So agents, yeah, some tasks are quite complex. It requires multiple steps, and a lot of these steps actually requires external services. For example, you may want your model to look up the internet, or you may want your model to look up the weather, things like that. So an agent is just an entity that can use certain external services, or even some for those of you who are familiar with coding, you can actually use some of the functions that you write. You can also you can also choose to ask humans questions, and then the humans provides the answer, and then makes use of this answer to accomplish a certain task. And if you have multiple agents, you can actually communicate between different agents, and in order to solve a more complex task. Yeah, so if you structure multiple agents in different ways based on the problem that you have at hand, you can actually accomplish like different tasks, for example. So some tasks may require a certain structure of agents. This is you can just experiment with all this. So this is quite task specific. Yeah. Okay. So another demo. Let me just open it up. Okay, this is an agents framework called AutoGen. So essentially, this framework makes it easier for you to create agents and also define tools that the agent may need to use. And then you can also chain different agents up into a single workflow to allow them to sort of like communicate with each other. So this it's written in Python, but they also have a web UI that allows you to do certain things easier. For example, I can define. So this task is about summarizing a YouTube video. So I can define a transcript getter, for example. So in the description, I'm just asking it to obtain given the YouTube video URL, I'm just asking it to obtain a transcript. A transcript can be obtained on the YouTube page. Essentially, that YouTube has an API that allows you to get the transcript. And then you can define a system message for the agent. So I'm just asking it to use this fetch YouTube transcript tool that I written to get a YouTube transcript for subsequent processing. So the model is 64, and the tool is this fetch YouTube transcript tool. So the second agent, what it does is after you have obtained the transcript, you summarize the key points and output in point form. So this is just a very simple example. So you can also define a skill. So a skill is the set of tools that the model can use. For example, to get a transcript. So this is using just a library a Python library to just obtain the YouTube transcript. And then you can define, for example, a transcript workflow. And in the workflow, you can add the different agents that you define. So, for example, if I create a sort of like a chat and asking it to, for example, summarize this video, and then I give it a YouTube URL, for example. Yeah, so on the back end, let me just open up the back end. Yeah, so on the back end, for example, the transcript getter is just running installing the library, and then also running the script, the function, the tool that I defined earlier, and then it gets the actual transcript. For example, I think this one is the Rhino or Grasshopper tutorial. It gets the entire transcript. I think it's passing it to the transcript summarizer. So the transcript summarizer is just your normal large language model. So this is just giving you a summary of the transcript. Yeah. So it then outputs the final bulleted summary. So for some of the tasks you may not need to define tools lah. Yeah, for example, for just a simple summarization. Okay. Okay, so that's it for text lah. For image, actually, I'm actually not that familiar with image generation models lah. I haven't been playing around with it much lah. But I think I'll just like briefly go through. I think earlier you all have already have a session right on image models. Yeah, so I think I'll just briefly go through. So I think the most important recent development which enable a lot of the image generation capabilities is this thing called the diffusion model. So essentially what it's doing is during training, it's given an image, it's simply generating certain noise, and then in the reverse process, it's just like it's just trying to predict the noise, and then removing the noise from the noisy image in order to get to the final image that you want. For example, image of a cat. And then there are some conditioning that those people who train the model can put in, like some text prompts. For example, you may say, please generate an image of a cat, things like that. There can also be some other conditioning like image conditioning. So this is the diffusion model. So these are just some applications. I think some of you may have already seen things like that. So I think this is using like inpainting, which is available on some web UIs lah. So it just I think probably inpaint over a section of an image, and then maybe use things like control net to sort of like have some control over the output, and then with a text prompt, maybe it's asking it to generate the architecture in the style of a certain architect. So yeah, so this is quite interesting example. So this is, I think, control net in this web UI called the Comfy UI. I think previously you guys have gone through, right? Control net, yeah. So it's just generating a depth net from an image, and then using it to condition the model to generate an output in the kind of the form of the depth net. So in painting, I think this is also using Comfy UI. Yeah. So recently there are also multimodal large language models lah. So for example, you can query an image. So what this is essentially doing is, I think, converting an image into, for example, in large language model for text, the inputs are text tokens, which are basically subwords. So what it's essentially doing here, for an image model, it's converting an image into text tokens. But in order to do this, I think they sort of train a layer in between. I think they call it the vision language connector lah. So it's essentially a projection layer that projects the image tokens into text tokens that is compatible with a large language model. And given a query, you can then sort of like query an image. So the language model they use can be any sort of like pre-trained large language model. Yeah. So this is just a use case like for example, if you upload an image, it can sort of like you can query the image and then it gives you a response based on the image. I think this model is called Lava, L-L-A-V-A. Yeah. They also have a playground on Hugging Face that you can test out. Yeah. But if you have like a powerful enough computer with a GPU, with a good enough GPU, like you can actually run this model locally. Yeah. And yeah, I think ChatGPT also has their own version, which is called GPT Vision. Yeah. That you can also do similar things. Okay, so some of the useful tools. yeah, the first thing I would recommend if you are familiar or if you're not so familiar is to have some familiarity with Python. I mean, I know that there are some certain UIs out there that can allow you to do certain things, but I think for more complex things, if you want to do more complex things that may not fit into the workflow of existing UIs, it's quite essential to learn Python. Currently, it's the sort of like the best support for most libraries that you work with when you work with LLMs or AIs, and it's quite a high level language. So I think it's quite easy to, quite straightforward, more straightforward than some other languages to pick up. And VS Code, which is an IDE, an environment that you use to write or run codes. And it also has some plugins to make the whole job slightly easier. And Google Colab. So Colab is an online platform by Google. So it's like a notebook where you can write codes, and you can run the codes, and you can also write some comments to explanatory comments to go with the codes. So why I'm bringing this up is I think for quite a lot of online tutorials, they are actually showing their tutorials using Google Colab, and you can just sign up for a Google account and you can run their notebook. And even for free accounts, they provide some GPU computes that you can make use of. Yeah, so I remember I trained a satellite segmentation model by using the free GPU compute on Google Colab. So it's an option if you don't have your own GPU setup. Yeah, you can share your notebook and other people can edit and run. Yeah, so I'll show another example, but it's just to highlight, for certain more complex workflows, you may then require, to pick up Python. You may want to chain different process, different workflows. You may want to make use of different models, and you want to chain the entire workflow together. And that's when you might want to, have this scripting tool to help you to, sort of like facilitate the different processes. So this is actually still kind of like a work in progress. So it's like a sort of like experimentation project. So it doesn't work that well now. But it's basically like a design concept generator where you can, input an image of your site and a mask, and then, for example, you can input your architecture brief. But the whole idea is just, to have a starting point to iterate on. So it generates certain designs for you to iterate on. But currently I haven't tuned it much, so the result may not be, it can be quite bad. Yeah. So for example, you can input, you can upload an image of a site and a mask. So this mask just, it just points out where your site is. And yeah, and then you can, for example, copy paste a simple architecture brief. Yeah, maybe just a simple architecture brief to build a new community center in Kallang, for example, where the site is, and the number of image per idea to generate. Submit. Yeah, so on the background, it's actually also using the agents framework. Pull up the backend. So It's using different agents. So the first agent is sort of like generate questions based on the brief. For example, do I need to use a tool? It says no, because this agent is not given a tool. And then it then generates a set of questions based on the design brief that you input. The second agent searches the internet. So the second agent is given a tool to search the internet based on the questions that the first agent generated. So for example, it searches for the demographic details, things like that, different architecture styles. And then based on the answer that is searched on the internet, it then generates a summary. Yeah, for example, it generates a summary based on the questions you ask and also the answers that you obtain on the internet. Yeah, this takes quite a while to run, so I will go back to the slides and come back later. Okay, so some other tools, Conda and Docker. So Conda is essentially, these are not really required, but Conda allows you to sort of like organize your library. So if you have a lot of projects, it might be a good idea to organize, to have isolated environments to sort of like organize different libraries. So it's so not everything clogged up in under one single project. And also Docker, which also creates an isolated environment for you to run your projects. This might be useful if you want your agent to run certain codes. Git and GitHub. So GitHub is essentially an online repository for people to store their different projects. And actually a lot of open source projects like Comfy UI, for example, the older gen, they are on GitHub. So you can just run a single command, git clone the address of the project, the repository, in order to get the repository and start using it. Yeah, so in terms of choosing LLMs, so currently there are proprietary LLMs or open source models. So for proprietary LLMs, if you don't mind paying a bit, so it's the usage usually by the cost is usually by your usage. So if you use more, you kind of pay more. So you can just query their APIs. For open source options, people mostly upload to Hugging Face, this online platform called Hugging Face. So there are a range, essentially a lot of different text or image or video models on it you can use. But it does require quite a bit of compute, depending on the model you want to run. If you want to run it locally, you might need quite a performant GPU. Yeah. So with Hugging Face, you can actually start a model or start running a model with just a few lines of code. It's actually quite straightforward to run using the Hugging Face library. This is just a LM leaderboard. So as you can see, I think most of the majority of the models that tops the leaderboard currently is still proprietary models like OpenAI's models, and also some of the Claude, for example, is from Anthropic. But there are also some open source models like Feng. Mixtro here is an open source model, and also Qwen, yeah, I think it's also an open source model. So although currently, the best performance models are still proprietary models, but I think open source is kind of like catching up. Yeah, I mean, I don't train models. I sort of just use the open source models because we are currently experimenting with Mixtro. Yeah, it's one of the top ones. And in terms of performance in your daily work, like for things like summarization or asking it to generate a response in a fixed way, for example, if you're familiar with JSON outputs, asking it to generate a response in JSON is actually quite good. Yeah, Mixtro model. Civic AI, I think I haven't really played around with this, but I think it's an online platform where different people in the community upload their image model checkpoints. So these people fine tune a certain open source model on a certain data set, and that model will be able to do better when it comes to generating that kind of image. Yeah. So this is a platform where you can download the model checkpoints that people upload. Yeah. I mean, from the image you see here, I think it's quite obvious where the focus of the people in the community are. Yeah. LangChain. So LangChain is a framework, designed to simplify the creation of applications that make use of open source. Sorry, not just open source, like any large language model. So it has some common functions like allows you to chunk a text, work with documents, interacting with vector database. So you can use it to work with to create like things like RAG workflows. You can also chain different workflows together. And it also has its own agents framework. So I think this is one of the most popular libraries to work with text large language models. And some image web UIs like A1111 and Comfy UI for working with image models. And some open source communities. Usually I go to Reddit and these are the two communities. Like Local Llama is for open source text models. Stable Diffusion is for image models that make use of Stable Diffusion open source model. So usually people will post like their experience working with these models or some of the results that people generate. And from this, then you can choose to dig deeper if you find something useful. Yeah. So the result I think has been generated. So after obtaining generating sort of like a summary of based on the answers that you obtain online and also the questions, it then sort of like comes up with a certain text concepts in text. So for example, the cultural mosaic, green canopy, things like that, and some descriptions that goes along with it. So this is another agent by itself. And once you generate this, then from this, you can sort of like generate some prompts that you may want to fit into an image model. So for example, for cultural hub, yeah. So this is asking the model to generate a response in a JSON format. So for models like ChatGPT, like GPT or Mixtral, it's actually quite good at following this output format. You then can pass on all these prompts to the image model to generate some image. Yeah, so these are some of the iterations that are generated. So I think the idea is like similar to generative design, where you input different parameters and you're asking it to sort of like you generate iterations based on your input parameters. So in this case, we are exploring the design space in using text because LLMs are able to work with natural language. So it's kind of like different from the more traditional paradigm. I think some of the image generated, like the design generated, are not that good, not that great. Yeah, but I think it's maybe you can, people can fine tune a model based on different architecture designs in the past. I think the important part is it's able to sort of like you can sort of explore the design space with text. And it can be a foundation to further iterate on. If you see certain designs that you like, for example, you can ask it to generate thousands of designs, and then you it sort of like then becomes a foundation for you to iterate further. Okay, so moving forward, I think we are increasingly beginning to see AI models as sort of like a intermediate layer between users and applications. So our interactions, traditionally we may interact with, for example, phone applications. I think moving forward, we are increasingly beginning to see people interacting with different applications with using LLM, using natural language as an input. So, for example, if you input a request, the LM is then able to make use of different tools to generate a response based on your request. And we are also beginning to see different multi-model AI models. So, when I was like preparing this PowerPoint just like 1-2 weeks ago, OpenAI just came out with a video model to generate quite amazing video results based on your text input. So we are constantly seeing, different modalities being added to the training data to train more capable AI models. So people are also experimenting with more complex agents workflows to accomplish, more complex tasks, where each agent may just focus on one single task, and then you link up different agents to achieve something more complex. But I think from my experience right now working with LM, I think it's still important to have this domain knowledge to sort of like expertise to sort of like guide the AI models, because models can be our current generation of models can be very smart in some aspects, but very stupid in others. Like it can make very silly mistakes. So I think it's important still to have the domain expertise to craft a set of workflow in order to guide the model towards something that is that users actually want. So I'll end with this image. So this is also generated by ChatGPT. I think it's quite funny on so many different levels. Yeah. So and it sort of like illustrates the current limitations of our current AI models because it's not essentially reasoning. It's just generating the result based on its training data. So it can still make like silly mistakes, and yeah. So I look forward to a good discussion. Any questions? Like you guys can talk about like your own projects that you want to things that you want to make for your hackathon.
So actually, it's quite amazing for a short period of time that you can convert yourself from technical field to another new and the world. So for now, right? Anyone here about questions? Okay, I have one question. Yeah. Slightly off tangent, but I mean, I'm very interested in your background actually. Now you are working in MES, right?
Yeah.
Yeah, it's like, is there, from your experience transitioning from, architecture and being an urban planner and MES, right? What are the, are there common challenges that you see in governmental agencies? I don't know, like whatever policies or bureaucracies, right? How does your architect lens, right? How do you see that? And also maybe, if you are building any AI applications currently in MES, right? Do you see maybe in the context of that? Yeah, sorry, not very different on this question. But yeah.
Sure. Actually, MES is the first government agency that I worked for. So previously as urban planner, I actually worked for Moro. So it's like a private design firm. But I think in terms of like things that we do in MES that touches on Gen AI, I guess we work with an internal stakeholder. So people from other departments that sort of like have some Gen AI use cases, like doing summarization, like people want to summarize their meeting transcripts into a certain format, like a certain format for meeting minutes, things like that. So and for this, like even the more simpler use cases we actually found that currently Gen AI, if you just have a simple input prompt, it's actually not able to generate a response so well, especially for those like long text inputs. So you sort of like still have to architect a set of workflow based on your understanding of the result that stakeholders want to achieve. For example, with the mixed-role model, it has like about 30K context length, but that's actually quite short for a very large, for example, for a very long meeting transcript or a very long document. So if you just input the entire document into this model, the result wouldn't be good. So I think it's about finding out what the user actually requires, working with them to actually get the output that they want, and also iterating upon this. So I think it sort of requires some like user feedback gathering and some things that we pick up as architects or in urban planning, to really understand the users, to see things from their perspective. Yeah. 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 So essentially for this workflow, you sort of like, for example, you want the one agent to generate questions, and then based on these questions, you do research. Based on this research, you generate a summary, and then based on this summary, you generate some design concepts, for example. So this is like a more sequential workflow. But actually, with different kinds of agent frameworks, you can actually ask the LLM to decide on the next course of action autonomously based on the input by LLM. So the workflow is not limited to a sort of like a sequential workflow that I showed. Yeah. So yeah, there are actually LangChain, I think, provides a LangGraph, this framework called LangGraph, where the agent can output the kind of action that that allows you to sort of like orchestrate the LM workflow. And in some of these agent modules, you can actually ask it to decide on the next action based on the input. For example, you can ask it to like generate the action in a JSON format. And for example, you can ask it to generate like yes or no. So if it's yes, run this. If it's no, run this. So there are different ways to orchestrate the entire agent's workflow. Yeah. No, we don't have to train an entire LM for this. So most of I wouldn't say most, but for LMs which are good enough, like definitely GPT-4, definitely like Mixtro, it's actually able to have to have a certain logic to decide based on your input prompt on the next course of action and generating the output in a certain format. So yeah, so no, you actually don't have to. Yeah. Yeah, yeah, yeah. Maybe for yeah, sure.
kind of simulations for agent-based simulation, but it's different definition of agent as well. It's change. It's like let's say you all the charge particles and try to find which is the of the same charge, like both of us both are positive, or they are attraction of opposite, but each of the charge will be different magnitude. So I'm trying to find assign a pseudo kind of attribute to the particles and run into like maybe pendulum thing from to allow the run a little animation, allow it to sort of like maybe an idea of master plan, planning, or even I think I know this is to address this I don't think it's possible to just show everything out the window and highly rely on AI or rely on purely on text and images, right? That's why this is what is because any other use of both token or maybe the text and text and image.
I think the problem that you described is like a simulation problem. So you for more for AI, it's maybe if you want your agents to interact in a less deterministic way lah. So but for that case, I think it's more deterministic. So yeah, so AI may not be AI may not be that suitable for this kind of use case. But in the context of like AI models, I think people from I think researchers from NVIDIA and they are experimenting with creating agents that interacts in a physical environment. So to allow these kinds of agents to be trained in a simulated environment lah. So in this environment, there are like maybe thousands of things that can happen to this agent, and based on the response that the agent gets, the feedback that it gets from this environment through interacting with this environment, this agent then kind of like learns to behave in a real world. So but that use case might be sort of like maybe more for the robotics field lah. Yeah, but yeah, for this kind of use case, I think maybe tools like Grasshopper or Kangaroo, maybe it's more suitable. Yeah, but you can ask the ChatGPT to give you the code. Yeah, you can do that. Yeah. Sorry?
You talked about input and output.
Yeah. Yes, in your input, you can put in generate the response in JSON format, then you provide an example of a JSON format. So that, I think for GPT-4 it's good enough. Yeah. It works most of the time, but for certain edge cases, you may have to come up with your own parsers. For example, if you notice that the LLM keeps generating mistakes in a JSON in a certain way, you might have to come up with your own code to address these kinds of mistakes in order to parse the output correctly. Yeah. There are also some libraries that you can use, that you can look at to sort of like guide the LLM models to generate output in a certain way. I think one of these is just called guidance. Yeah. You can look it up. Yeah.
We can't.
Okay, so hi everyone here. We have some just admin matters before you all can discuss in the groups. Just some updates on the schedule. Can see my screen. Perfect. Just remove this. Okay. Okay, so there's this new update for everyone who needs CPD points. We are currently in the process of finalizing it, but there's a caveat because you need to attend all the sessions that's going to come out from 11 March onwards. Okay, so those who need CPD points, please scan the code. We will provide you the link also. You need to fill up your full name, your last 4 digits of NRIC, your BOA number or SIA number, and then we will tabulate. And those people who need CPD points, from next week onwards, we will have a sign-in and attendance taking session because this is required for admin. It will be hybrid as well. So if you can listen in online. We understand you have very busy schedules. Yeah. So most important. So how many sessions are there? There will be, I would say, 3 more compulsory sessions. Yeah, to spare everyone of the thing. I think the final group meetup in April is optional, as we have early on said. But we try to make every session a bit more productive. So we try to now merge things together. So next week, we will have Graphisoft coming in, and then you can have your team meetup. And then the following week, we have our very own Luke, who's going to share very interesting things from Landis podium for development. I think we all can learn something as well. And also there's a 4th group meetup. The 5th one on the April is optional because we open this space for everyone to come and discuss if they need it. If not, it's not necessary. But you need to submit your final things, and then there's a presentation on 22nd April. So you need to attend all these 3 sessions in order to get the CPD. Oh, there's one more session on 18 also. Is it? Did I miss out one? Okay, I will let you all know the schedule. So the next part is you have to attend all. Okay, that's all I mean. This is my thing. I'm not sure whether we get but the plan is very simple. For today, you should come up with a technical execution plan in your group. That means you kind of list down how you're going to achieve it technically. I think by next week, you should kind of start doing the technical plan and do some trial and testing to figure out whether you are being too ambitious or not too ambitious. And then I think hopefully by then, you all can do some final run and things like that. So yeah. Okay, then 17 will be the submission. So hopefully all these teams can work together. This is the schedule for the presentation and award ceremony. So on April itself, this is also a CPD pointer with the 22nd one. That means all the teams will present. People who need CPD points must be present. And then there will be judges here. And those winners will be announced on ArchiFest. Actually, we have booked the ArchiFest as one of this highlights. So the winners will be having a sharing session and a moderate panel discussion. This is in Marina Bay Sands. Yeah. Those people who missed the past workshop, actually, we have uploaded all the things on YouTube, so you can watch it. You just search SIAYAL, you can find it. They have very little subscribers. 22 only. Maybe you all can view it more. Then the last one is, actually we have a Telegram group, but we use the SIAYAL Telegram group with a category for hackathon. So there will be, we push out all the announcements from there, so you can join it. So that's all from my updates. If you're in your groups, you can start the discussion together, and also please fill in the form for the BOA and the SIA points, CPD points if you need it. Any questions?